Welcome everyone to the last session of this Friday here at SQLBits. We're at the Power BI variables session. We're going to talk about N and DAX languages and how to use and benefit from the use of variables. I'm Renato Lira. I'm a data platform MVP based in Brazil. I have a blog, and I come from this self-service part of this world. I was a business analyst, and then I specialize in N and DAX, exactly what we're about to talk in the following minutes. First of all, when we talk Power BI desktop, it's not a single product. It's made of several products. 3 of them are the core. The one that does the ETL part, the ones that handles the data modeling, and the one that handles the data visualization. Power Query, the semantic model, and then the Power BI report itself. When you talk about the engines, there are several. When you talk about Power Query, there's a mashup engine that runs the M language. When you talk about the semantic model, the engine is Analysis Services that runs DAX queries. And when you talk about the data visualization, I don't think they have an official name for that, but that's the interactive part of the report in the Power BI solution. Let's talk a little bit more about the Power Query environment. First of all, whenever you open Power Query, there's the left pane with all the queries that you added to that session. And that session is very flexible. You can write queries that outputs a table. You can write queries that outputs a record, a list, a scalar value that can have several data types such as string, date, number. And you can write functions. So the queries that you see at the section, the query panes, are pretty much flexible. And you can choose which of those queries you can give to the next engine, which is the Analysis Services, so you can enable or disable load of some of those queries. In each query, you have several of steps, applied steps to connect to the data, make the transformation that you need, and then the output of that query will be usually the last step. And in every intermediate step, you might need some interaction. For example, for every row, let's add another column that has some specific business logic. But when you talk about iterations, is evaluate the same expression for every row or every item on that set iteration list. So I'm going to summarize them into only one field here. And when you write an expression for that iteration, you can, depending on how complex your logic is, you can expand into several steps and so on and so forth until your logic is completely implemented. All right? So every layer has an output. Usually, when we are in the Power Query realm, the last step is the output of the query. But you can change your M code and change that behavior, okay? For example, I highlighted here the steps is the last one, but at the variable lane, I choose the second to last. There's no obligation for you to, the last step is the output of the variables that I just started. They all, in the M language, use the let-in syntax. It's actually a syntax sugar for a record. Those of you that are a little bit more experienced with Power Query, there's the record. Let-in is a syntax sugar for record. But let-in is easier for us to read, and the UI recognizes let-in as the applied steps. So when we get to the demo, we're going to deep dive a little bit about that. Every variable or query or steps have a name. It's usually automatically generated for us. They pretty much never makes any sense. I know it's hard, but you should, when you are building your Power Query solution, give meaningful names. You can use ChatGPT for that task. It's pretty good. I've seen the Dataflow Gen 2 Copilot. It doesn't does this task yet, but it's a question of time for it to actually help us with that. And every variable does a lazy evaluation. What is that? It doesn't mean that if I declared all of those steps in the variables lane, I will actually execute all of them. If somehow I put in some code that I don't reference, I don't need them anymore, it simply isn't evaluated. So it's good when you are creating and debugging, so you can choose the first, the second, the third step of your calculation that you put into a variable, but sometimes you forget to get rid of that variable that you actually don't need. So the engine is smart enough to not execute that part of code. The same here, in the steps lane, for example, I might not need that second record variable, so it doesn't get evaluated. Okay, let's go. Whenever you are in there's a section with queries. Within a query, I have several steps. Within the steps, I might have iterators. Within that expression for that iterator, I might have a set of variables. Within that scope of that highlighted table, I can reference other previous steps. I can access other previous variable names. But by default, I can't access the previous iterations set of variables. For example, I'm in iteration row by row. Per row, I'm going to have an expression that I create variable A, B, C, and D. When I finish evaluating for that first row, when I go to the second, A, B, C, and D from the previous rows is not accessible for me. It's like its own word. But with the M language, we have two functions that actually give us the possibility to access the variables that we pre-calculated in the previous iterations on top of that iterator, which is list accumulate and list.generate. They are not that trivial. They are worth a 50-minute session here at Cicobits, but you can do some complex logic that actually might require that behavior. But with that cell, I can reference every other variable within my own lane. Okay? I can still access every other previous step on the previous lane, but the current one that I'm actually giving the instruction. And I can still reference every other query that is not the current one that I can evaluate. So in this, when you see in this perspective, it's really, really flexible. Unless you create a circular reference, a circular dependency, you can do pretty much everything. That's why when you see the diagram view of Power Query, sometimes in some real-world projects, they're not as straightforward as the demos that we see. Because Power Query actually allows pretty much everything. So be careful to not create a circular dependency, and please use meaningful names for those steps. You're doing a favor for yourself later whenever you have to debug, and for the next colleague that might take that work that you actually set up. Okay, let's go to the demonstration. It is actually the last session of the day, so I really already did the codes, and we might get off a little bit early. First of all, this is the Power Query environment. Let me enlarge a little bit for you. And I have several preset instructions that uses the M language that has those 12 queries. I have first a query that I just return a year, a scalar value. That's a number. A second one that I return a string, SQL bits. A third one, which is a different type, that's a parameter. That's especially when you want to build custom functions. It's pretty handy. And I can write a record. That's another Lego bricks that you can make using the AIM language. Also, I can create a list from 1 to 100. So I can add several queries that return several different types of values. Okay, it can either be auto-generated within this AIM code, but I can connect to the source and filter with my specific data. I have here, actually, I copied, Control-C, Control-V. I have the output of a DAX query. If the second half of this presentation, we're going to talk a little bit about DAX. But the output of a DAX query actually has the complete lineage for that field. Date, column, fiscal year. Table product, column, color, and so on and so forth. It helps the DAX engine to actually do the filter manipulation that it's required to set up that output. But as at the receiving end, I actually don't need to know the row lineage reference, table and column. I just need the column name. So one common approach is, okay, I have the output of a DAX query, and I have some function to create, and then bulk rename all of those columns that you see here. Pretty much everyone has these brackets under the column name, which is the actual name that I need to know. So I changed the data types. I'm based in Brazil, so the data are different. I had here also, so I had this DAX query, which has all of those applied steps, as if they are actually variables, okay? And I can, this year has no logic. I have this custom that points to the year, and I have this that points to the previous. That means the output of this DAX query query pane within the Power query here actually doesn't evaluate those two applied steps. And I can prove to you. I can come here and put error. Sorry. SQL bits error. This step, we have an error, but the output of the query actually just works. Because of what? Of that lazy evaluation that we talked previously. Okay? So on top of that data, that has the data that I need, but with weird column names, I might want to create a function to rename them. But first, let's talk about sections. As up to my knowledge, every Power Query, doesn't matter if it is Excel, Power BI Desktop, Power BI Online, Dataflow Gen 1, Gen 2, Power Platform, whatever, they only have one section, which is the current section where we are creating the instructions to be evaluated when we hit refresh. Okay? I think maybe in the future they might give us access to other sections. For example, if you have some custom functions, you put it in a central place, and every other child Power Query instructions might point to them. But as of now, we only have the current query. But what do you have under this section? We have every reference of the queries themselves. So I have the year, the event, the columns renames, the last step, and then the lazy evaluation. That's a little bit now. So this section is the first layer of variables that we can actually set. Okay? We have the iterator here. Here I already used that function that renames the DAX query columns. It already does the job to translate this DAX query, date, fiscal year, product, color, and so on, with fiscal year, color, category, sales, more meaningful names for us to work on top of that. But on top of that, I can, for example, group rows. And on top of that grouped rows, I, for example, increase the granularity. I had several columns. I just picked 3, so I have less. It has now 54 rows, and the source had 246. I just changed the granularity of this calculation. And I can add a column here with some expression. Sorry, I can add an index column, so I can know what is the first row, the second row, and the last row with Power Query is 0 based. So if I want the first, I actually type 0. If I want the 10th, I actually type 9. Okay? So I added an index, and then I added a custom, I added a custom a variable called custom with another set of variables. First of all, let's go back a couple of steps before we continue with that. When I have this DAX query here, I can go to the advanced editor, and within the advanced editor, I copy paste. That's why that's this weird binary. But I have a let. I declare every variable that I might need, and then I have an in with the variable that is actually the output of this lane. Okay, and whenever I have 2 variables in between, I just put them with a comma. Every new variable ends with a comma, but the last one, because this is a syntax sugar for the record expression. Okay, so that's how we declare variables here in Power Query. And I can nest that let in, that outer let in with an inner let in, for example, with that example with the iterator. I can open the advanced editor. And then I have a let, table equals something, comma, reduced table equals something, comma, result equals something, that no need for comma, since this is the last variable that I'm declaring. In the output of this group is the result. What I'm doing here, I'm pointing for my previous step. So I'm transversing let in variables. And then on top of that table, which has an index column, I'm performing, first, I'm buffering only those 2 columns that I need, which is the sales information and the index. And then I'm adding a column, I'm creating an iterator, which adds this next row sales, and it adds on top of that reduced table, smaller, less memory depth. I want the sales information, and I want the index plus 1. So I want the next row sales. This is quite complicated, but the point is, I can, in inner let in, this let in here that I highlight in red, okay, this in here, I can reference the added index, which is part of the outer let in. I can either reference a query pane variable that I might have. Okay, so I have this function that actually does the logic that's automatically for every row. Doesn't matter if I have 1 or 100, renames the columns. But I could do it with two ways. I can write this. This is a valid expression, but it's pretty hard to understand what's going on here. Do you agree? You should rename columns on source, then I have a list zip that ends here, and then I keep going on and on and on. This is valid, but this is hard for us to understand what has been done. Doesn't matter if it was you from a week ago. You're going to suffer how to understand. I actually did this expression this morning, and as of this, I can't read it. So that might be another way for us to understand it. Let me show it in the advanced editor, which is pretty much straightforward. You still have to understand how AIM language works, but it's far better to read. So I declared and opened a new lane of variables, and then, okay, my variable table equals source, which points to the previous lane. The column names, I use table.column names on top of that. So I have that table under brackets column reference for every column on my source. Then I transform those column names with that reference using the list.transform and using that function here in blue, text between delimiters, which is our goal. Okay? On top of that, I'm going to use that list.zip, which puts a list inside of a list, and then I use the rename columns with that combinations. It's still not that easy, but way more easier than the previous one that I just shown you. Okay? So whenever you use variables, you can take a complex methodology and step by step create and solve them, and with the benefit that it's better for you to, whenever you need to do maintenance in the future, you go back and then correct or just understand what has been done. Are you hearing me okay? Okay, perfect. So those steps that I just put here, let in, I might need to do the exact same steps in other DAX queries that I might encounter in other workloads. Do you agree? So N is flexible enough for us to, okay, if I will do it over and over on top of a source, I can copy that and create it in a function, and it use it everywhere I need. And whenever I need to do some maintenance, I can just change that one place, not dozens that I might reference it. So I might copy it and create the function. There are a couple of ways of doing that, but I just copy it and remove the last step, which was the table, and put as the parameter for that function. And then it just works. I can come here, select DAX query, invoke. It created a new Power Query query here with the name of the function that I just gave and the input. Okay, it just works. Let's remove it. I have a specific example here. Let's open the advanced editor. As the first layer, as the first lane of the query, I can have a first apply step, the second, the third, but my in statement, I don't have no obligation to put the previous one, the last variable that I named. I can point to any variable that I just have in the previous. So that's not that good because the UI doesn't like it. It's complaining, it's showing the whole code let in. But whenever I fix it and point not to source and push to custom 2, it was supposed to work. Okay, but live demos, right? But if the UI can, I don't know what's happening, but you might be able to revert to the applied steps. So don't do that when you're here. And the last step that I want to show you in this Power Query environment is the lazy evaluation, which the output of this query is that last step, which I intentionally put the error, but if I add here and point to the source, it just works. So if I have invalid code or something dead end, I can put some if this, do that, if not, do that. One might break, but if you put the if with the right logic, your query won't break. It won't be evaluated, that bad part. Okay? Questions? Perfect. Let's go back to the slides. The order of evaluation is non-intuitive, right? Because I have the query panes with all the queries that will be passed to my analysis services, will be passed to my data model, my semantic model. And since I can, in every step, reference any order unless a circular dependence is hit, that's quite a mess. So you can see, imagine you have several queries, source A, source B, transformation 1 and 2, which are those paths. Source A's are used in transformations 1 and 2, and source B only in transformation 2. But we actually need the output, which will be the enable load queries that I will use to write my DAX and populate my reports. So the only tables enabled are those two, but I need those source A, B, transformation 1 and 2 in order to orderly apply the transformation that I need. But the actual order of evaluation is not intuitive. It's not from left to right. It first takes the first output, and then as of that lazy evaluation that I just shown you, okay, for output 1 I need transformation 1, which needs source. And then I also need transformation 2, which also needs the source and needs the source B. There is an internal optimization with the Power Query, which is called streaming. You can Google for Ben Gribaldo. He has several really deep dive topics about the M language, and he explains that concept. But actually, I started from the output and then go back into the source. And if your source is not query foldable, you might hit a severe performance problem here, okay? But that's life, and that's why you read Chris Webb blogs and try to overcome it. On the other hand, after I'm done with the output 1 and send them to the model, I start working with output 2. Okay, there's some level of parallelism, but you might think there are separate instances. And when you trace back output 2, you actually need those 3 queries. Unfortunately, the source A, B, and every other intermediate query might be hit several times. That's why sometimes your Power Query, oh, that's such small data, and it's so slow. So unfortunately, that's the way it is. This is the same for the basic implementations with Power BI Desktop, the Power Query in Excel, and Power Query in Dataflow Gen 1 if you have no premium available for you. So the orange here is enable load, and the other are disable load. That's the best practice if you need to work with it. But if you have Dataflow Gen 1 with premium, I tell this by experience, just enable load for them all. With one exception, if your source has complex types that has like that table or list or record, it won't work. You have to enable load only on fully expanded data, when you actually can see scalar values for every combination of rows and columns. That's only the only observation. If you have complex, you can't. But if all scalar values on your table, enable load with Dataflow with premium capacity, it's going to be pretty fast. And Microsoft likes to make our lives easier. With Dataflow Gen 2, this best practice changed. The best practice especially with now we have the separation of compute and storage. Especially if you leverage one lake, you will set an output destination for your output tables. That might slower things if you use the previous best practice, which is enable load to all. That's why they changed the name. In data flowing tool, that is not enable load. That's enable staging, which has a different meaning, and it's out of scope of this session. But as a default, only enable disable staging for everyone. I think this slide is incorrect. Disable staging for this, and only set the output destination. I need to correct it, but that's the default. But if you have some huge, like millions, tens of millions of data with pretty expensive operations such as a merge, you might have performance benefit if you stage some of those source queries, okay? And that's why they also recommend you to do the medallion architecture, bronze, silver, gold, because your bronze will be in one lake. One lake is fast source, not the actual source that you might have in your companies. Okay, so now let's talk about the semantic model. So I first talked about the first engine, the ETL engine that runs on side by side with Power BI. Now let's talk about the analysis services that runs the DAX language, and which is the why Power BI is Power BI, because of the tabular model. Remember, DAX is a query language that talks to your model. If your model changes, your output might change. So one of the pitfalls I've seen everyone doing is, okay, this is my model, 5 seconds. The report and measure, report, measure, report, measure. You just forget about your model. You just forget about how you set up the tables, star schema, not relationship, regular, limited. So you need to be seen at your model at all times, even though if you see that model every time. And whenever a little change that you might do to your model to add some extra feature, you might make that measure that works into a measure that don't work. Sometimes it's huge. Everyone sees, okay, it's wrong. But sometimes it's minimal difference. You might take months or years to even notice it. So look at your model at all times. What are the main places that you can write DAX code, DAX expressions? Calculated column in tables, an actual DAX query. You can write with the DAX query view. It's more evident for most of people. And a measure, which is the go-to for 90% of the DAX code that you're supposed to write. There are several other places that you can write DAX measures, such as format strings, calculation groups, detail rows, RLS, visual calculations, DAX queries. That's duplicated. And for sure, I'm forgetting some other place that you can actually write DAX expressions. When you are writing a DAX expression, everybody here follows SQL BI, right? You're supposed to use var, return. And that's how I define the local var group. That's local for that specific branch of my calculation. So that's not an obligation, but it's advisable for you to declare one or more variables and then return the output that you actually need. So the return here is mandatory whenever you are in a local var group. So if you are in a measure or calculated column, but let's talk measure to make it clear. I can open a var group and name the first var, the second var, the third, and whatever variables that I might need. And why they are called variables? Because the output, the type of each variable can either be a table or a scalar value, number, date, string. It cannot be anything between. So a variable can have a table or a scalar value, but once it is computed, it becomes a constant. It doesn't vary. So it's misleading, but a variable, when it is computed, is actually a constant. So whenever I'm in a specific step, I can open a second var group, which is a second pair of one or more var declarations with a return in the end. Pretty much the same of the let-in syntax that we just seen within the Power Query, but different engines, different teams, different mind, different needs, different implementations, right? So I can open a var group. Each variable, the output type is either a column or a scalar value, but once evaluated, it's constant. And I can open an iterator. So on top of 1,000, whatever rows you have, you can do the same expression with row context for every base table of that iterator. And on top of that iterator, you can open another var group, and so on and so forth, until you finish the calculation that you might need. Okay? In Power Query, was not the default, but we had the possibility to do list.accumulate or list.generate to apply recursion or soft recursion. Here in DAX, we simply don't have that. Okay, and for me it's a problem because I work with cash flow analysis, and you either put up a code that is really, the performance is really, really bad, or you just can't deliver the calculations without these soft recursion like measures to do, for example, a cash flow analysis on top of several parameters or scenarios. Okay, so there is no recursion in DAX. That's why whenever you need a recursion, you have to do it elsewhere, either in Power Query or a notebook, Python, T-SQL, whenever language that you might need. But you are limited to those scenarios that you pre-created in your ETL process. You don't have the beauty of the DAX for slice and dice several filters and then see the output. You're kind of limited here. Okay, we already said variables are constant once they are evaluated. But let's focus on that scalar value on the first var group that we just creating. I evaluate the first. I might evaluate the second, the third. The order might be different, okay? Because of that lazy evaluation, we can skip some. But when I hit the iterator, I can create an expression for that base table, and then I go to another var group and keep going. In every stage, for example, this stage that's highlighted here, I can reference to previous variables. Doesn't matter if it is in the same var group, for example, this var group 3, or the previous var group, for example, var group 2. I can reference them and use them to do my calculations. That's why the main scenario for use for variables are actually to get rid of that earlier function that's messed everyone's head. Okay, and the variable, they are constants. So whenever context row plus filter context that you might have, whenever you evaluated, that piece of code will be saved. Okay, so here, when I'm in this last step, I can reference to any of those orange. But if I finish the calculation for the var group 2 highlighted table, I go to the next variable. That branch is out. They just throw it in the trash. I cannot reference to that variable name, for example, here. I just can't. Okay? It's like a tree. Thanks. It's like a tree. It's going up on branches. Demo time. I have some expressions here that we might write. That's a measure. And I have a first var group A, B, C result. And within the result, I open a second var group just over kind of declaring A again. What is the output of this measure if I put it on the report? 26. Other number? There is somehow of a conflict here. I have the same variable declared in two var groups, but the closest var group wins. So if I take this expression here, I see actually 26. Okay, I can have conflict names within variables. There are some certain rules that I can name a variable, for example, table or date, but if you try to write, the IntelliSense will complain. You just change the name, put it on the score, or V, or whatever naming pattern that you might encounter. So I have this order showing that a variable can store either a scalar value or a table value. This is a table constructor, 2 rows and 2 columns. Here I have the scalar output. I can just put it here. It's returning 1 as expected. And I can change this expression to this function that I actually love, to CSV. That, sorry? Okay. You're seeing right. Oh, not this one. I can use this function that I actually love, that you can materialize in a measure with a scalar output somehow the structure of an intermediate table that you might need for your expression. So I'm going to change it. And then I see 1, 2, 3, 4, 1, 2, 3, 4, just what I am expecting. So I can store as an output of a table or a scalar value in every variable. I can write this constant here. So I might, with the sum of sales, put it in a variable, and then try to use calculate to remove filters of this value. I can go back, I think it's this one. I already spoiled the output. But whenever you're writing it, if this output wasn't a constant, you're supposed to see the same value for every row. But since you evaluated the sales variable outside of this calculator, or with the every filter context for every cell here in place, it will actually filter Australia, Canada, France, and every country region that might have. So one mistake that I see a lot of people doing is using a variable reference as a calculator or calculate table expression. It just won't do anything, because once evaluated, within the context where it was declared, it becomes a constant. Okay? Let's go here to this other expression. I said here with DAX, it performs lazy evaluation also, as well as in the end. So I have the first, the second with an error. The result is first. So I'm skipping this second. So if I take it here, lazy, it actually returns without error. But if I put the second here, it actually has the error with the specific error that I just wrote. Okay? It respects context. Let's see this expression a little bit. So I have this, I have this measure context, which takes the country region. And I have a new context here, with I added with the iterator add columns on top of the all that removes any filter context, and take the exact same value of country region here. If I go to this example, this measure, whenever I'm returning the measure context, it returns what I expect, the same value of the country in my actual measure. But whenever I change it and call the iterator output, which kind of took the same lineage, but within a different context, I'm putting controls, because if I put 2 CSV, it might get a little weird to see. But we have 7 countries, and it has all the 7 rows. So it respects the context. One thing that we can't do here is I can write a parent measure that calls a measure, and within that child measure, I try to refer to a previous variable of my parent. In Power Query, you could do that. Here in DAX, you just can't. Okay? And I think it ends. Let's go back to the slides. Oh, I'm a little bit behind. So, as I've shown you in this last example, whenever I have a measure reference, it's like, okay, forget all of the past branches of our groups, of the previous var groups. In this example, var group 1, 2, and even 3. So, whenever every other variable, you cannot access them within that code. Why? Because a measure is a joke. I don't know if you play cards, joker. It can be put in several DAX query with several group by context with several places. So the measure is, okay, forget the previous, you just can't use them. But you might see, okay, I have some calculation that I'm doing here. It might be logic for me to do not discard that value that I might recalculate over and over and over and over. That's why the model has several optimizations that in most scenarios, they're like they were declared in the right place. But we rely on the optimizations. It's not perfect, so you might hit some scenario where the performance improvements that the engine behind DAX actually do, they just don't solve for your scenario. So you might be in trouble. So every visual is fed by an automatic DAX query. And that's the structure of a DAX query. If you've been watching Marco's sessions, he's shown a lot. But it starts with a define block where you can define measures, columns, or tables, which you're kind of changing your data model. But you can also declare variables. And here I call it global variables because it is in the define block. You don't need the return here. Why this is important? And if you're writing measures or calculated columns or tables, who writes the DAX measures for you is the actual engine that runs the report. So normally you don't have access to that part. That's why most people oversee it. Why is it important? Because this, going back a little bit, that's optional. I may put something in the define block, but I have to have at least one evaluate statement. I can have multiple. Whenever I have multiple evaluate statements, let's say I have 5 here, I can reference to every other variable that I might have been declared at the define block that I call global measures. And on top of that, I can, but I can't reference to other siblings, other evaluate statements. In Power Query, we could. In DAX, it's a little bit more rigid. We just can't. And inside that evaluate, you can create several other var groups with whatever iterations or branches that you might need. Okay, but on top of the modified model if you use define measure, column, or table. And you can reference those variables. If you see the DAX query automatically generated, it pretty much does all the job with global variables, not local variables. Okay, I'm at time. Let's go a little bit more. Whenever you use a measure, you kind of break that chain. You have no access to previous states. Okay, if you have any questions, I'll be around here. And thank you. Please provide us with feedback. Can I take a picture?